This is Algebra 2 with Trig, working on the 8B review. So we can use a calculator on this portion. We're going to solve the triangle. So we're looking for the measure of angle A. We're looking for the measure of angle C. And we're going to be looking for side AB. We could also call that side C, lowercase c. So it'd be obvious that we could do Pythagorean theorem because we have two sides looking for one side. So we'd be doing hypotenuse squared equals leg squared plus leg squared. The hypotenuse is 21. One of the legs is the square root of 297. We're going to square that. And then the other leg, we don't know what it is. We can call it AB if we wish. So 21 squared gives us 441. And of course, when you square square root, you get what's inside. And then we'll take our 441 and subtract the 297. That's very convenient to be 144. So when you take the square root, of AB, we're going to get the value of 12. So AB is the length of 12. Now we need to find our two angles. Well, I can use trig inverse. To do that, opposite over hypotenuse, that's sine. So sine of theta equals the opposite over the hypotenuse. So we would do sine inverse of 297 over 21 equals theta. So I brought my sine over to the other side of the equal sign. So my sine and my square root of 297 over 21 were together, and my theta was isolated. Now I wrote it on the right side, no big deal. So we have sine inverse, so second inverse gives us a -1. That means we're looking for an angle. That's the square root of 297 divided by 21. So we have a 55-degree angle. And that's here at angle A. So you could easily put an A in this spot so you knew specifically that that was A. And then this would be the measurement of angle A. That might be more helpful. So we're sure to put it with angle A. And then one easy way to do this is to subtract our 55 from 90. And we get our 3485. Or you could recalculate it and do cosine inverse using the square root of 297. You could use 12 also, but if 12's wrong, I don't want to get my answer wrong. All right, we're supposed to find the different trig values from angle A. So the sine of A, this could be an A, I guess, but sine of A would be opposite over hypotenuse, so the square root of 297 over 21. Now when I look at 297, I see that that is 2 and a 9, which is 11, plus 7, which is 18. So I know that 297 can be divisible by 3. 297 divisible by 3 is 99. Divisible by 3 again. So 33 is made up of 3 times 11. So what we're looking at is 3 times 3 times 3 times 11. So we have a pair of the same numbers. So that could be 3 root 33. 3 root 33 over 21. And then that can be reduced to square root of 33 over 7. A little crazy looking. Okay. From angle A, it would be 12 over 21. And we should reduce that. 3 goes into that 4 times. 3 goes into that 7 times. Tangent would be opposite over adjacent. So we decided that that was 3 root 33 over 12, and that can be reduced to square root of 33 over 4. Cosecant is going to be the reciprocal. So that's going to be 7 over the square root of 33. Then you would need to rationalize the denominator. And that gets 7 square root of 33 over 33. This would be 7 over 4. That's convenient. And then this would be 4 over the square root of 33, which when we rationalize it, that would be 4 root 33 over 33. Now we're going to use this point, 3, 4, to determine our trig functions. So if we have point 3, 4, so 3 is our x, 4 is our y. I know that my r, this looks to be a Pythagorean triple, 3, 4, 5, or you can do your Pythagorean theorem, and you'll get 9, 16 is 25, so r squared equals 25, so r equals 5. Pythagorean triple. So if this is our theta, because it's the angle closest to the origin, opposite over hypotenuse, so 4/5, 3/5, and opposite over hypotenuse is 4/3. Same idea again. Here we're going to want to determine what the radius is. So really it's just the Pythagorean theorem. So we go 12 to the left and 14 up. This just gives us a reference of what numbers we're looking at. We're looking for our radius. So our r squared is going to equal negative 12 squared plus 14 squared. 144, 196. That's 4 less than 200. So 200 more to this would be 344. And it's 4 less than that. And then we can take the square root. Now, can that be broken down? Well, of course it can. Okay. I know you could break this down by 34 times 10, which is 2 times 17 and 2 times 5. So it looks like 85 times 4. Okay, so the square root of 4 is 2. And we don't have the square root of 85. It doesn't break down at all. Because 17 can't be broken down, 5 can't be broken down. They multiply to be 85, and the 2's are your pair, so it comes outside. Reference angle. Well, if we just think about, this is not on the unit circle. So this would be 7 pi over 7. This would be 14 pi over 7, so it's definitely in between there. Half of 7 is 3.5, so this would be 10.5 pi over 7. So it's going to be here in the third quarter. Third quadrant. Half of 3.5 is going to be, so if we're at 10.5, that's a total of 3.5. So that's 175. There it is, 175. So 175 would be 875 right here, and we need to be 9, so it's a little bit past the halfway marker. Just an approximation, doesn't really matter. All right, so what is our reference angle? We are past pi. Pi is 7 pi over 7. And we went to 9 pi over 7. So we're 2 pi over 7 past it. So the reference angle, theta prime, would be 2 pi over 7. All the drawing was just a visual. It wasn't a requirement. Negative 222, well, that would be negative 90. Negative 180. 30 more would be negative 210. 12 more would be negative 222. So it would take 22 to get to 200, and then 20 more to get to 180. So that sounds like 42. So our reference angle is 42. Remember, it's always a positive number. The reference angle is always a positive number. Okay, here we're talking about cosine being a negative. .75. So you can think about that as being 3/4 of the way, all the way out to 1, negative 1. So we can think about going up, think about coming down. What is this angle? Cosine is negative to the left. When we do cosine, we talk about answers in these two quadrants. So if I do cosine inverse of negative 0.75, I'm going to get my theta value. I'm going to get the angle that makes that. I don't believe that that's a unit circle number. So negative 0.75, cosine inverse, we're looking for the angle. So that's going to be 138 degrees, 0.59. So if that's 138.59, this reference angle, the amount that it takes to get to 180, we would subtract that angle away, and that's going to be 41.41. So 41.41. We want to know the other angle in the third quadrant that is also a cosine of negative 0.75. I guess that would be right here, right? Nope, sorry. It's all right. So that's going to have that same 44.41, and that's going to be past 180. So now we have to do 180 plus 41.41. Oh, that drawing's down here. I'm drawing that in the wrong spot. I'm sorry. Of course. So we need to do 180 plus 41.41 because the angle that we're trying to get to is this one. If this here is 41.41, then here is 41.41, and that's past 180. So we add 180 to it. So 221.41. Now there's a way we can test this. Okay, so we're going to do cosine of that angle. This is an angle. So of that exact angle, don't round it, do the same value. Now we're expecting to get negative 0.75, exactly. There it is. So that was a good test. That answer is between 280 and 277. All right, we're looking for the sine of theta. Pythagorean identity is when we say sine squared of theta plus cosine squared of theta equals 1. That's a trig identity you're going to use a lot in pre-calc. So we know our cosine is negative 3/4. That's what cosine is, and we are squaring it. We don't know what sine squared is. So we square it, we get 9/16. We subtract that to the other side. So we have 1 minus 9/16. So 16 minus 9 is going to be 7. So sine squared of theta equals 7/16. This would have been 16/16 minus 9/16 gives us 7/16. And then you take the square root to figure out just sine. So that's the square root of 7/4. That is our sine of theta. Here we have a ladder on a tree, palm tree. The ladder is 15 feet long. So the ladder portion is 15 feet. It reaches 12 feet up the hill. Here we can draw it a little bit bigger. And we're looking for the angle. Then at what angle does it make with the ground? The ladder. The ladder makes this angle. It's an angle of elevation. So opposite over hypotenuse. So sine of theta equals 12/15. Well, we can simplify that. Sine inverse of 3/5 is going to be our theta. Sine inverse of 3 divided by 5 is going to be the same thing as the sine inverse of 12/15, because that's just a reduce. I reduced that wrong. 3 goes into that. Oops. See, it's always good to check your work. Way to mess that one up. So 3 goes into that 4 times. 3 goes into that 5 times. How about that? Okay, let's try that again. So sine inverse of 4/5 should be the same thing as sine inverse of 12 over 15. That was a bit scary. It's good I checked my work. So that's the angle this should be making with the ground. And then the last one. We're going to determine the distance that the rock is thrown if it's at 25 miles an hour at a velocity of 12. Now, when I wrote this one, I was picturing skipping a rock, but it's not how far it skips. That's not really accurate math that we're doing. We're doing you're tossing the item with a velocity at a specific angle. So our distance that the rock is going to travel at 25, okay, it says miles per hour. Oh, I don't like that. It should be probably feet per second, but again, that's what happens when you make up story problems. 2 times theta, 2 times 12. So our distance of 625 divided by 32 times sine of 24. That is not a unit circle number, so we can't get as much of an exact answer. So we'll just use our calculator and say 625 divided by 32 times the sine of 24, and our distance is 7.94. All right, there you go. Got the backside now. Okay, our 6 trig functions. At 120, that is going to be negative a half for x and positive root 3 over 2 for y. That is the coordinate for right here. So we know that our sine of 120 is going to be root 3 over 2. Our cosine of 120 is going to be negative a half. Our tangent of 120 is going to be y divided by x. So we have y divided by, so we multiply it by the reciprocal. And that gives us negative root 3. Then we can do our inverses. So that's going to be 2 over root 3. And rationalize the denominator. So that's 2 root 3 over 3. This secant would be negative 2. And cotangent, when we do 1 over the square root of 3, that becomes root 3 over 3. So those are our 6 trig functions. 7 pi over 6 is right there. That's going to be long for x and short for y. So our sine of 7 pi over 6 is negative a half. Our cosine of 7 pi over 6 is negative root 3 over 2. Our tangent of 7 pi over 6 is the reciprocal of that, which is going to be root 3 over 3. That's going to be your y value divided by your x value. So we multiply by the reciprocal. And you rationalize that. Root 3 over 3. And it's positive. Then cosecant of 7 pi over 6 is the reciprocal. Secant, we're going to get negative 2 root 3 over 3. And then here we're going to get cotangent of 7 pi over 6, and that's going to come out to be just root 3. If you flip this upside down and rationalize, you get 3 root 3 over 3, and the 3's cross out. So you just get radical 3. Evaluate. So what is the cotangent at 300? 300 would be 30 degrees past 270. It would be 60 degrees short of 360. So that's going to be short and long. So we know we have half for x and long for y, negative root 3 of 3. Cotangent of any angle is x over y. So we can do our x value times the reciprocal of our y value. The 2's cross off, get negative 1 over root 3. And just like we've done before, and it's going to be negative because it's in the 4th quadrant. So we're at 2 pi over 3. This is 1 pi over 3. 2 pi over 3 is right there. And that's short, long. So short is x, and long is root 3 over 2. That's our y value. Secant is the reciprocal of cosine. So it's going to be the negative 2. Next, we're going to be looking at sine inverse of negative a half. So in terms of geometry, what we're looking for is where is y negative a half? Negative a half would be halfway to negative 1. So it's going to be one of these two spots. We know that sine uses these two quadrants. So our angle will come down here. You should realize that that is a long distance over and a short distance down. So negative root 3 over 2, negative 1/2. So we would often call that 330. But we've learned that in using inverses, that's going to be considered negative 30. Because we're coming down. We can't go all the way around. When we do inverses, we only use quadrant 1 and quadrant 4, so we cannot go through quadrant 2 and 3 to get there. We want to go the shortest distance, shortest angle. So negative 30 degrees. Where is tangent negative 1? Well, thinking about tangent, we know that we have positive tangents here. We have negative tangents here. We know out at the ends is going to be root 3 over 2, negative 1/2, or positive a half, negative root 3 over 2. But it's the middle coordinate, which you get the same x value as you do the y value, except for the sign. So that when you do y over x and multiply by the reciprocal, those all cross off and you get negative 1. So that's happening at negative 45 degrees. It would also be considered negative pi over 4 for the radian. Over here, this would be negative pi over 6, because that's what 30 degrees is pi over 6. On this side, it's 45, just like it would be for the middles in quadrant 1, but we're negative root 2 over 2. Now we're going to talk about filling out our unit circle without any additional help, any notes. We're not just copying it. We'd be at 0 degrees and 0 radian. That's 1 to the right and 0 up. That would be 30 degrees, pi over 6 radian, long, short. So our long side is root 3 over 2, and our short is a half. Y is short. It's a smaller distance. The two lengths that are the same will be at 45, which is pi over 4, root 2 over 2, root 2 over 2. 60 degrees, which is pi over 3, because 60 goes into pi 3 times. This would be short to the right and long going up. Short, long. At 90 degrees, we'd be at pi over 2, and that's 0 for x, and that's rise up 1. 120, 2 pi over 3, or you could call it 1/3, 2/3, 3/3, 4, or sorry, 1/6, 2/6, 3/6, 4/6, and reduce it. Some people like to count that way. This is short long, so negative short, and y is up, so it's positive, long. This is 135, 1/4, 2/4, 3/4. And that's going to be negative root 2 over 2, positive root 2 over 2. This is 15 degrees again. And that's going to be 5 pi over 6, because we had 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6. Every 30 degrees. That's why we skip the middle bars. Skip the middle bars to go over 30 each time. 180 degrees, which is pi. 1 to the left, 0 up. 210 is 30 degrees more. 7 pi over 6. That's long for x. And that's long or short for y. Four over 4, 5 over 4. You got to count your way around. It can be very helpful. That's negative root 2 over 2 and down 2 over 2. 240 degrees. 1/3, 2/3, 3/3, 4/3. So that's 4 pi over 3. Short for x, long for y. One half, 2 half, 3 halves. 3 pi over 2. And that would be 0 for x and negative 1 for y. 300 degrees. 1/3, 2/3, 3/3, 4/3, 5/3. So 5 pi over 3. Short, long. $15 degrees more for the short distance. 1/4, 2/4, 3/4, 4/4, 5, 6, and 7/4. So that is root 2 over 2 and then down 2 over 2. 11 pi over 6. You can count that if you want. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 8, 9, 10, 11 sixths. We skip the middle bars because those are not multiples of 30. We're over a long way and we're down a short way. And there's the whole unit circle. Good job, everybody. Good luck.